Hey, welcome back. In this part of the series, we are going to discover the concepts of iterables, iterators, and generators, and why and when we should be using them. So, what is an iterator? An iterator is an object that has a method named next. Every time we call that next method on a collection such as an array, it should return another object that has a couple of properties. The first property is value, which holds an element of the array at a time. The second one is done, which is a boolean that tells if there are more elements within the array. So that's a simplified definition of an iterator. To have a better understanding of it, let's create one. First off, let's start with creating a function that accepts an array as an argument and returns an iterator. The I variable here is to keep track of the position we are at in the array. It is used to assign the values of the properties that belong to the object returned by the next method that we are creating next. So every time we are calling next, we are incrementing the counter. Then we return an object which has the done and the value properties. Since we are incrementing the counter every time we call the next method, we initiated it with -1, so when we call the next method the first time, I should be equal to 0, aligning with the index of the first element of the array. The rest is pretty simple. Don's value will be true if we reach the last index of the array, else it will be false. The value property, on the other hand, will contain the element from the array if Don is false, else its value will be set to undefined. Now let's create an array and see the result of calling the next method from the iterator we've just created. As you can see, the first call returns an object with Don set to false, since there are more elements within the array, and there is the value property assigned with the first element of the array. That said, let's call the next method a few other times. As you see, after the third call, done is set to true and value is always set to undefined because we have already reached the last element of the array. Now you might be wondering, why would I need to create an iterator and what is it exactly used for? To answer that question, let's first understand what is an iterable. An iterable is basically a collection that has a method which returns an iterator. Furthermore, an iterable needs to have an iterator in order for us to be able to iterate over its element using the for of loop, which also came with ES6. Examples of iterables in JavaScript are string, array, typed array, map, and set. Each one of these iterables has already a built-in iterator, so we don't need to create one for them each time we want to iterate over them using the for of loop. That said, let's create an array and iterate over it using the for of loop instead of using the classic for with a counter. As you can see, the for of loop looks cleaner and more concise than a usual loop. We just have to create a variable. That variable gets filled with an element from the array during an iteration. It gets used within the body of the for of loop. Then its value is replaced by the next element of the array during the next iteration. So what happens behind the scenes is that when we pass an element to iterate over with the for of loop, the first thing the for of loop will do is to check if the collection we passed includes an iterator or not. So if it does, it will check if the iterator contains a next method, and then it keeps calling it automatically and filling the variable x in this case with the value of the property named value from the object returned by the next method. The same thing keeps occurring until the property done is set to true, in other words, when the end of the array is reached. Again, you might be asking, if an iterator is created by default within iterables, why would I need to create one as it's already there from the beginning? Well, actually not every collection is an iterable. More precisely, custom objects don't have an iterator and therefore they are not iterables. That being said, let's create an object and see what we will get when we try to iterate over it using the for loop. As expected, an error shows up which is self-explanatory. The object we've just created is not an iterable. So, to make this object iterable and make it so when we use the for loop on it, it displays each value from the range set by the properties start and end, for example. To add an iterator to our object, we need to use the well-known symbol.iterator and type almost the same code as we typed earlier. If you're not familiar with symbols and well-known symbols, you must watch the previous part of this series in which I've talked about them and gave an example on how they are used to make built-in functions like search compatible with custom objects. Now let's analyze the code. We started the counter with start, and again the -1 is there because of the incrementation that will take place at the first call of next. Then we created the new constant end that has the value of the end property because end doesn't exist within the object returned by the next method. To better understand the idea behind that, here is a counter example. Say we use this.end here directly instead of creating the end constant. This.end within the next method will be filled with the value of the property end that belongs to the direct parent object contained in the function, and as you see, the object returned doesn't contain any property called end. That means that this.end will be always undefined, which makes the value of the DOM property always falsy, which in its turn leads to an infinite loop, as again the for loop will keep incrementing the counter until DOM returns true. So, an easy solution to that is to just create a function scope variable containing the end value from the grandparent object and then pass it to the next method. And there we go, now applying the for loop on our object works as intended. If we take a look at both of the iterators we've created, you'll notice that they are a bit verbose and give the impression that they are kind of complex with all that nesting. Fortunately, ES6 engineers provided a cleaner way of creating iterators, which is generator functions, or simply generators. That being said, let's transform this function into a generator. The first thing to do to tell the JavaScript engine that this function is a special function, aka generator, we must add an asterisk symbol before the function identifier. Then we can get rid of all the verbose code and use a new keyword which is yield, then set a value. So, as shown in the console, the generator function works the same way as before. It returns an object with a done and value properties, except that the values here are different. That's actually because the values are now set by the yield keyword. So, if we use yield again and assign another value, you'll see that the value of the second object will change. Now, since we want to apply this iterator on the argument array, we can use yield on each of its values. We can even do better by using a for loop within the generator function, since an array is already an iterable. We can do the same thing with the iterator of our custom object, so to do that we need to add the asterisk symbol, then use the yield keyword and the value to be returned during each iteration of the for loop on the object. Again, we can enhance the code using a usual for loop this time. And there we go. So with that being said, make sure to subscribe and I will see you in the next part of the series.